Welcome to a new episode of Manufacturing Matters, where we talk about the automation technologies that help manufacturing to continue to matter here in the U.S. and across the world. Today, I've got something special for everyone. I'm sitting here with Manny Romero from Teledyne.
Thank you.
Oh, Manny, so we've probably spoke the first time 20 plus years ago, I want to say.
Yeah, absolutely. Yeah.
You know, and I knew you from all the standards work that you've done with A3 over the years. So really, thanks for taking some time out today.
It's really appreciated.
Manny, let's start with the background. All right, so tell us a little. Well, first of all, let's just tell them about give your title and what you do at Teledyne, and then we'll dive into the giant company you're representing.
So, currently, I'm product manager for the area scan product that we have within Teledyne.
Right.
It cover the Teledyne Luminera brand, the Teledyne Delta brand, and some of the Teledyne Sphere IAS portfolio.
Okay.
So it's been doing it for, as you highlighted, a long time. In product management, 16 years, and 9 years prior to that, still with the organization, but in different role in the R&D.
Awesome. So you just touched on a couple of product lines at Teledyne. But let's talk a little bit more about that, because I don't think people always understand the breadth and the fact that Teledyne can be a one-stop shop for so many of our automation needs.
Absolutely. From the different type of sensors that goes into our camera, so 1D cameras, 2D cameras, so the matrix type camera, 3D cameras. You know, we're also very well known for our frame grabber, and we have software capability. We have 2 software packages that have been out since 20 plus years.
Right. Sapira
processing. We had also Sherlock, that was for end users, so people that absolutely don't know anything about coding and they want to get up and running. To add, image processing, and we even added lately the capability for deep learning within that Sherlock software. So somebody that does not know programming whatsoever, they can go up and running. Part of that group include also our smart camera that we also have with that group.
Yeah. And I want to delve a lot deeper into that, because it's amazing you can combine object-based programming and Sherlock with the capabilities of deep learning. But let's not totally get ahead of ourselves real quick, all right? So we were just talking about the breadth of the portfolio. It's about 1, 2, 3D. Is there more there before I start asking? Because I want to talk about, you mentioned earlier, the Luminera acquisition and how some of those sensors are starting to really make a difference in what you guys are producing.
Yes, well, from the Luminera, we had from that acquisition, it was a portion that was more microscopy oriented,
right?
Which was not originally what, let's say, Delphi was doing.
Right.
So that was just something that was added to the portfolio. Same thing with the acquisition of photometric and Princeton instruments. So they went more into the scientific.
Right.
That technology got added to the family. The sensor technology that we had with the acquisition of B2V bring back, that whole concept into what we can offer to customers. So when you said one stop, you're absolutely right. We're covering anything that anybody could need in that industry.
Right. So Luminera, they came from the scientific sensor space, right?
Yeah.
And Princeton brings a little bit of the infrared spectrum in.
Yes, and obviously photometric was really those high-end scientific camera.
Right.
That actually you were talking about the different type of camera. I mean, even if we've been doing line scan, so 1D for a long time,
right?
2D and 3D has been more recent. The 1D, we have not stopped, innovating into that space. Some of our latest product that we just announced was the Axis, which is the image sensor contact. The beauty of that is the concept of line scan, but with the integrated light and lens. So it's relatively easy to use, to install. So we brought that experience into that space. Additionally, another product that we announced a few weeks ago, which was the Linea 2 multispectral.
Right.
Super interesting, right? We're going elsewhere with different wavelength.
Now, is that pre-select the wave bands that you're interested in, or are you able to select
No, they're predefined.
Okay.
So very useful when you're talking about food inspection.
Right. Yes. Especially a large area of virgin and vegetable inspection.
Yeah, free fall type.
Vectors.
Yes, free fall type, and you want to
Water
identify the good, can be coffee, beans, rice, name it, right?
Right.
The good from the bad, and then in the 2D realm, again, we never stop to innovate, which is why it's so cool.
Yeah.
In the 2D realm, with our Teledyne Clear IS group, which is in Richmond, in British Columbia.
Okay.
We introduced the new 5 GigE camera, the Forge. We're seeing as how 1 GigE was a dominating interface in the industry.
Right.
The 5 GigE is really the next big thing because people just want to go faster. And we pushed the logic even further by making sure that the camera itself has an even faster internal acquisition, so that we can do a very interesting thing, and that either the mix of the sensor and the link speed is not the limiting factor. So, for example, right, you want to do a wide dynamic range imaging, you want to see better, you make a double capture very rapid, and you could you could sequence to a series of image at different wavelength to actually see more on whatever you're trying to inspect. Again, in the realm of the 2D, we came out with I guess I would say right now, the smallest 67 million pixel 10 GigE camera you can find on the industry. Super tiny, 49 by 49.
Board camera.
Sorry, 59 by 59 millimeter.
Wow.
No, but it's very optimal for such a large resolution. And then again, in terms of innovation, using our sister company, E2B, added some of the fastest sensor that there is out there. So we have, again, even faster version than the 67 that I talked about. I run at 90 frames per second. Very interesting for multiple BX, battery inspection. So it's very, very, very cool. And then the absolutely latest we came out with was it's a 2.8 million pixels. So you might say, 2.8, it's not that much, but it's running at 1,200 frames per second. So you're like way out there in terms of throughput.
When you mentioned earlier about 5 GigE cameras coming on, it made me think about handling the thermal load, thermal dissipation. And you're running, at that kind of resolution speed, at that kind of frame rate. Obviously, the technology has come a very long way from, 10 and 20 years when I was first starting to get my head around it. I'm just curious, can you give me, how do you manage that?
I would say that you don't need to go 20 years. Even in the last few years, newer FPGAs, the PHY, much more efficient in terms of power dissipation, and obviously a good design and making sure that, we thermally can dissipate EE properly, especially when you push it, that far. So that's again, product that we're, very excited to see coming out into play. What was the name of that? What is it? This one? For the Falcon 4?
Yes.
Yeah, Falcon 4, which is using the CameraLink HS standard, which is fiber optic, so distance is not an issue.
Right.
And then you can go up to, if I would compare the standard versus a 1 GigE link speed as a reference point, our fastest one is basically 70 times faster. It's like 70 times the 1 GigE camera.
So one of the things we wanted to talk about was standards in the interface. I mean, there's so much confusion between CameraLink, between CoaXPress, USB3 Vision, GigE Vision. There's probably no one better to ask this question to. Can you simplify it for us? What is the sweet spot of each one of these? And as a follow-up question, is there any one of the standards that Teledyne doesn't support right now?
Actually, no.
With the point gray acquisition?
We actually have it all. And actually, your question is very, it's very on the dot. Some people don't initially realize the pro and the con of each of them.
Right.
So if you're looking at a longer distance, so you don't have like a 2 meter limit, a 2 meter that from your processing engine or your computer or an embedded for your camera, and you need to go, I don't know, 20-meter. USB 3 Vision is not the ideal solution.
Right.
You're gonna feed that exactly. But that's a great interface when you got a nice embedded system not that far, and you want to DMA directly from the camera to the computer.
Yep.
That's a great interface. It include the power with it. Super for that. Now, if you want to go far,
right, security applications or even just large plants, right?
Actually, I can go as far as, I'll give you a very concrete example, far as in a stadium.
Right.
Multi-camera around, sports event.
Which is what it's all about.
And it happened a lot.
Yeah.
Obviously, people want to, well, it is what it is. People are betting sometimes, right? So they want to know about, okay, which team's going to win?
Yep.
How do they do that? Well, they themselves, they want to feel secure that they're looking at all the data to guarantee that they win. Winning is something else, but they will be looking at the advanced.
At least they'll be informed when they lose the money.
They're gonna lose. They're gonna look at the advanced statistic.
Yeah.
Well, that is coming from the main player that are buying our cameras to actually go in those stadium,
right,
to capture those data, synchronize all the camera. So that's actually a scenario that would mix the duty of GigE for the distance,
right,
and for perfect synchronization with PTP. So a multi-camera synchronization, very precise. You can go down easily to 8 nanoseconds accuracy,
right,
from camera to camera, very far. It does include power, so if you have a very good systems, easy to cable.
Easier to, yes.
If it's a robotic application, right? You got some nice cable that we can find on the floor that are super flex,
right,
so that they can go on those systems. It's perfect. You need to go much higher bandwidth, then you got to start looking. Camera-Link, I would say, it was great when it was created, in the early 2000. And I remember part of the, in the comedian talking, and, the nightmare of cabling back in those days was the main reason why it was creating that standard.
Right.
Ease of use for customers, interoperability between the cameras and the multiple frame grabber. It was great. Time went by.
Yeah.
And then, that's where we saw CoaXPress rising. Again, same principle, added power like the Camera-Link did. Higher bandwidth, because the first version was CoaXPress 6, and people wonder.
Right.
So 6, it's equivalent of, I would say, equivalent to a 5 GigE link speed by wire. And, there's 4 of them, or can go up to 4.
Right.
Then eventually they moved to the CoaXPress 12, which is a 12 gig range, but because of the technology of how it encodes on the wire, I would say it's a fair statement to say that a 10 GigE Ethernet is equivalent to a 1-lane 12 GigE CoaXPress. That's something that people have not realized.
Right.
But those, in terms of absolute bandwidth, they're equal because of the way the data get encoded on the wire.
Right.
And then if you want to go even faster, that's where the Camera-Link HS standard that created, which are almost at the same time that the CoaXPress, and then obviously now we're way up there in terms of throughput, and it's available with fiber optics, so distance is not an issue.
Right. Right.
So it kept moving and forward. I'm expecting from my view, I expect that within the next few years we'll be hearing more about GigE Vision. Right now, as we say, 1 GigE, 5 GigE, 10 GigE. I'm expecting in a few years we'll hear way more about the 25 GigE, 50 GigE,
right,
100 GigE. I was joking to some of our sales guys in the office. I was asking them, says, do you know actually where that broadcast industry is right now? I was saying, I don't know. So where is it? Well, right now they were talking about the 800 GigE that they're using.
Wow.
And that basically is the platform of what the whole GigE Vision is based on. So it basically laid the table for a lot of available bandwidth for the future.
So how does broadcast do that? With multiplexing, essentially, to be able to achieve the 800?
No, they're using multiple lane of of again fiber optic.
Right.
And they're instead of being 4-wire, they're 8 wires. That's why those modules they're called. I think it's OSFP. You might have you heard about the QSFP, right?
Right.
Or SFP module.
Yes.
So SFP module is a single connection.
Yeah.
QSFP, the Q is for quad, and the O is for octo. So it's basically 8 lane of 100 GigE each of them.
Front of like crazy.
It is so.
Is there a latency difference between, I mean, like the CXP and the industrial GigE, or are they all pretty much deterministic safety rated?
No, I would say that they're. I'm a fan of GigE,
Right.
for the simple reason that the nature of the interface is designed that you got, error correction. It allowed a packet resend. So a good system that is designed will never lose data. Now, having said that, there's a portion to it that I think has been minimized over the year, which is the quality of implementation on the software side, on the computer side. Because of our background in line scan and our customer base at Teledyne's been asking us to push that bandwidth further and further. It's much tougher to transfer on line scan than area scan because the amount of line you're getting on the wires is high.
Right.
Same thing with one of the product that we didn't cover, but it in terms of capability, it follows the same line as our 3D camera, right? Sending that profile on the wire. So we have our Z-Track 2, which is 5 GigE, and it transfer profile, pretty much the same concept of line scan getting a line, being able to sustain that high throughput.
Right.
When you got a really good product, but if you don't have a good software at the end of it that basically sustain it, and the definition of sustain, it means that when our customers start to process on top of the acquisition and they really want to take advantage of their computer, it's not to say I'm going to buy a 8-core CPU to only use half of them, right? They want to make sure that they utilize that as much as possible.
Right.
When our customers start using they start using the processing with the acquisition, and they're getting to that close to the ear of the what the computer can do.
Yeah.
That's how you know if you got a good driver or not a good driver. I know that I'm very impressed with what our guys were able to do over the years, and the last, I guess, since 2005, I think. So you're talking about basically a 17-year-old experience on that matter of
listening without having to use the frame grabber. So
no. Yeah, that's exactly. That's the quality of implementation.
And it's funny because just a few years ago, when everyone would quote bandwidths for a specific standard, it was always, that's the burst. That's what it can achieve for short periods of time. And everyone was really thrilled and happy that they didn't have to sustain it across, like you do in line scan, infinite imaging, tenuous imaging systems. But now we're pushing right up against it. I mean, that's incredibly cool.
But I would say,
yeah,
I do not minimize the frame grabber to the equation, because as we got more and more application pushing that bandwidth
right
further and further, I see space for having, let's say, dedicated, call it GigE frame grabber. That would, when you really, really want to push, imagine this, right? 50 or 100 camera GigE. You're talking about 100 GigE of bandwidth.
Right.
Now at that point, you could have a very good software, but you're pushing the boundary too far. So there is still place for those,
Yeah, that's not going to be a PC. That's going to be something without having to go to some kind of rack mount monster.
Yeah. And, you might want to ease that data acquisition by using a GigE frame grabber, for example.
Yeah, especially if you're going to do any kind of pre-processing to kind of cut it down
exactly
into the multi-core. That's okay. So we talked about the benefits of GigE. We talked about where CXG is. We talked about bandwidth and speed. We know that we've got strong latency there. Has a little bit more on the hardware cost us. We need a frame grab. That's the CXG. We talked about USB3 Vision being great for embedded systems for short runs, right? And I suppose there's actually a thermal benefit there too, right? Because USB3 is so low power.
Yes. Yeah, no, there's definitely an advantage for the power consumption.
All right. So let's pivot to what everyone's talking about these days, but we've been talking about it for 10 years, and I'm thinking artificial intelligence, of course, and deep learning, right? So, but it's been a lot of the smoke and mirrors until I would say the last couple of years for me, when I'm actually seeing automation companies eat their own cooking, so to speak, right? I mean, we're not just selling AI deep learning solutions out there. We're actually using it ourselves to optimize our systems in a certain way. So let's talk a little bit about Teledyne's approach to DL.
Well, for AI, we also obviously have solution from a software perspective.
Right. The Astrocyte.
That's the Astrocyte. Astrocyte is our tool within the sepal processing or Sherlock. So Astrocyte allowed the customer to make his model in a very easy manner. So we understood how there was a complexity in tweaking the parameter to get good results. So we made sure that we would find a way that can generate the model very rapidly and efficiently.
With high accuracy.
With high accuracy. So that's one portion. Now, as you highlighted, AI is not everything. It coexists with the traditional function. And
honestly, have you ever heard of an application that was ever solved solely from using artificial intelligence or deep learning software that didn't need some kind of fiducial find, edge find, something?
There is, but they're very basic.
Okay.
They're very basic. But if you want to do something a little bit more fancy,
right,
or smarter, then that's where your AI will be your co-process to whatever you're gonna end up doing.
A hybrid solution.
An hybrid solution.
Yeah.
I know that from a Teledyne perspective, it was an initiative, and you might have seen it on the booth at the show today, which is our. We have actually a camera that basically it's designed to enable customer to offer a solution, but it's really more, I would say,
this is a smart camera platform.
It's actually we have the smart platform, which is called the BOA, and that is more oriented for I would say a lower performance type of application, the way it can process. The IVS product that we have, it's targeted to work with customers to tweak and customize the solution for the customer. So it does include whatever sensor that he's need, whatever AI processing.
More like a platform and a product.
Yes, absolutely.
Perfect.
So that I do expect to see more and more with the year to come, obviously.
Okay, so we mentioned the Astrocyte making things simple, right? I mean, and that's let's go deeper into that, right? How do we help it? Does it help us to identifying outlying data that's undermining our model efficiency?
It does,
and I think it's something about its ability to grow.
Well, yes,
or maybe evolve.
Well, it's not the Astrocyte that does that part,
right?
It's the Astrocyte is really to create the model. But within our platform in sepal processing with the AI capability, we added capability that when you have actually an online system and you find a new defect,
right,
that we're not already trained, instead of go back to the drawing board and retrain everything, we added capability that we can update that model so that on the inline system you're not going down, like you're just updating it and it keep going. That's important. The other part about AI that we've been hearing a lot lately, right? We're talking about those buzzwords, going in the cloud, right?
Yep.
So many of our customers, they're not ready to share data and losing control over it.
Yeah.
So they want to make sure that it's at the edge or it's within their control. That's a portion that I don't know how which moment or if ever we'll have customers really ready to really upload.
Yeah, I have the same questions, and I need to talk with Ericsson and others about 5G. I mean, just in terms of security. And although it was interesting, was speaking with Amran earlier today about how they're building cybersecurity systems into their SysMac platform, right? So, I mean, the industrial world is waking up to the dangers that are out there. And so all we're talking about is liability risk, right? And companies trying to protect themselves and their customers,
Yes.
make sure they're building quality products. If I could follow back up on the AI, when you were saying it learns new defects, how much operator involvement is required?
Oh, it's very little. Like at the second that, they notice that something that was absolutely unforeseen is seen,
Yep.
they're able to revalidate the model with Astrocyte, and that generated, I would say, an update file that can be just used in the inline
Right across the network,
Yeah.
and get to the individual inspection notes. That is so cool. That is so cool. Okay, so I'm out of questions, but I want to just throw the big open question, right? So Manny, as you look out here, we're at Automate 2023 right now. Everything that's cool and nifty is on that show floor right now. But what excites you most? Oh my God! I know it's not a fair question,
That is not a fair question,
and you're not allowed to say like the jazz band out of the network.
One of the things why I've been in that industry for the last 25 years is exactly about that evolution of the technology. It keeps moving. It's super amazing what kind of new problem rise from customers.
Right.
And in every field you can think of, from recycling, feed sorting, PCB inspection, like name it. Right? People are pushing the boundary on every angle, and to work with a bunch of amazing guy that keep push that boundary, and sometimes they're partners, sometimes they're competitor.
Yep.
It's a big industry and it's a small one at the same time, right? So from the decision making, new idea that's coming out, or a new sensor technology, or a new type of wavelength, and how people are get creative
from technologies to cross.
From every little piece of all those products that got together over the last 25 years has just been seriously amazing. So, but passion is basically what is driving us, and same thing with the many people that I work with. We've been working for many years together. We have new bloods that come out with new ideas, but that passion is still there, and that's really what fundamentally excites me about that industry.
I swear the last 2 years seemed like a tornado, or something has hit our industry in terms of automation technology. The amount of change, the fulfilled promises that are coming true. And when you think about AMR and you think about all the autonomous things they're no longer just in the R&D and in the conference tracks, but they're right over there on the show floor.
Right here.
And I'm wondering this, are we truly seeing an exponential growth and acceleration in technology, or are we just coming off a 2-year COVID hangover? And it's like, all your favorite bands who wrote 2 or 3 albums during COVID, and then suddenly they release them all at one time. We have is this a Taylor Swift moment, or is this nope? The world's just changed. We flipped a switch.
Yes.
That's what I think too.
Yeah, definitely. I mean, people are more, everybody care more about environmental today. Absolutely. So the growth,
Don't have a lot of choices on that way.
the growth of electric battery. Right?
Yes. Yeah.
Be green, recycling, making sure we're not wasting.
Yeah.
Food sorting, right? We're talking about now we get into that
Resources.
making sure that there is no waste, right? Grade 1, grade 2 product, or recycled to make juice. So we're not wasting anything.
Yeah.
So I guess there's more conscience about all those elements being important, and that's why we're right in the middle of it. But
And I think you might have identified something really important there. Like in the past, automation has been driven by we want to make people's work lives better. We want to help our customers to build products cheaper, faster, safer.
Yeah.
But right now, those traditional drivers have been joined by a real push, because the world is so fast changing. I mean, when you talk about going to electrification of vehicles, I mean, this is This is a sea change, and this is something we've all talked about for 40, 50 years.
But lately,
Yeah, yeah. And I mean, then, throw in autonomous vehicles. It's not going to be too long before we've got that figured out, too, across the vast majority of our roadway, which brings in so many different imaging modalities, both on the safety side, on the navigation side. I mean, there's just, it seems like applications are just exploding, and they're outside of the factory, which is one of the coolest things, I think, for us. It's just almost like a payoff at the later in our careers, We've been stuck in industrial environments for so many years, and now our technology is everywhere.
Yes, smart agriculture.
Which is something I'm super excited about, actually. I know autonomous harvesting and the ability, much more optimization for pesticide placement and, again, resource optimization.
I even seen going back to more mechanical method. Not using the
pesticide,
but going back to mechanical chopping.
Right.
So you need AI to start looking at those plants to identify which one is the right one, which one's not the right one. Right. Make sure you cut the right plant. And because obviously, if you're going with mechanical, it's called scissors.
Right. Right.
Or it's again prevent more pesticide back into the.
Which
the land.
Would be better for all of us, that's for sure. That's fantastic. Manny, I want to thank you so much for taking a little bit of your time out of one of the busiest days of Automate this year to talk. I mean, this is one of the more insightful episodes that I've been in, and I've really enjoyed it to the max. So thank you so much.
Oh, thank you so much
for coming here today.
It was great.
Thanks, man. So this brings to an end our latest episode of Manufacturing Matters. I hope you liked it. Feel free to watch it on your favorite podcast platform. If you want to join us someday, shoot us a quick note through social media or at manufacturing-matters.com. And until next time, just remember that wherever you are around the world, manufacturing still matters. Till next time.